to turn things over to our next set of presentations, which is engaging students with immersive and interactive virtual reality technology.
Welcome everybody, and thank you for coming to our presentation. My name is Dimitrios Bolkas. I'm an assistant professor of surveying engineering at Penn State Wilkes-Barre, and I have an engineering degree from Greece, and then I did my PhD in geological engineering in Queen's University in Canada. My research interests are mostly in laser scanning, point clouds from drones, basically photogrammetry, and usually for Earth monitoring applications. But one of my most recent research endeavors has been on virtual reality and how we can use virtual reality technology to enhance engineering instruction.
Hi everybody, I'm Jeff Chiampi. I'm also from the Wilkes-Barre campus. Before coming to Penn State, I spent about 10 years in industry doing a lot of software development. At Penn State, I mainly teach computer science and a little bit of game development. And currently, all of my research has been tied to engaging engineering students using some of these emerging technologies. We want to start off today by giving you an overview of the 3 separate projects we've been working on. They're all very similar, they all overlap, and they're all geared towards improving engineering education. But there are some big differences between them. Today, we're going to be talking about our primary project, the first one we started on, which was related to taking a physical surveying lab, one that's done outside, and then changing it so it could be done in virtual reality. So we wrote some custom code for that. The pictures you see on your screen are of the VR lab we built. We have 6 workstations, and you can see one of our students using the workstation below. The next project we started was 360-degree videos. Now, while these aren't interactive, they are immersive, and they let students see the tutorial from a spatial perspective. So we're going to be showing that off a bit. And then kind of our newest offset is some augmented reality. Using a tablet, students can hold up the tutorial, and we can overlay some markers in the real world to help them through their actual physical surveying lab. I do think it's important that we just take a quick moment and differentiate between some of the terms we're going to be talking about today. We're going to be talking about virtual reality. And when we're talking about virtual reality, we're talking about replacing the world around you. So we're giving you a brand new world. In our case, we're doing this with the Oculus technology, but it could be done with a few other vendors as well. And then we have augmented reality. AR is when we're adding things to the real world. Currently, this is done usually through like a cell phone camera. You're holding up the camera. Amazon has a product right now where you can view a piece of furniture in your room. That's an example of augmented reality. It can also be done with things like glasses that you wear, but those are more bleeding edge technology. There's also something called mixed reality, which we haven't gotten into yet. Mixed reality takes the augmented reality approach, and then it adds the ability to interact with those objects. We do have a Microsoft HoloLens right now, and they seem to be at the forefront of this technology, but we haven't started actually developing surveying labs that use any sort of mixed reality yet.
So the initial motivation for us, to develop those or to go into immersive technologies was some of the challenges that we have in surveying engineering education. So one of those is, for example, that these instruments are very expensive. Just consider that that top right instrument that you see on that image costs $15,000 if it's used, more than $20,000-$30,000 if it's brand new. These students, they need to spend a lot of time with equipment so they can be familiar with it, but we have a limited time in the labs. Surveying can take place in many different environments and locations, city environments, construction sites that can be, kind of dangerous. There are several safety protocols there. they can be in urban environment, rural environments, mountainous terrain, flat terrain. But at the same time, we train students in a certain location around the campus. So that kind of limits the ability of the students to train their skills in different scenario settings. Then we have also the weather, because these labs take place outside. So based on the weather, we might cancel 1 to 2, 3 classes every semester. So it's not uncommon for me to again going referencing that top right image to see me shoveling to find some monuments on the ground, which is not very pleasant both for the instructor and the students. And also now with, for example, COVID-19, we also have students that they cannot even go physically to the campus. So that's why we want to start working more on immersive technologies and kind of enhance instruction. And in terms of some other challenges that I think, some other disciplines can also relate. When we have a lab, the instructor can take a considerable amount of time to explain all the instructions in that lab. Also, the tasks that we are doing, they need to be, the students need to have like spatial awareness, so they need to visualize what they have to go and do outside. In addition, another challenge is that students also always need partners, so to complete those labs. So sometimes, even though we switch them roles, they might not get fully understand all the lab procedures. And as we said previously, some of the sites are, we cannot really recreate some labs, and we cannot access some sites. During the lab, students can have questions, and this can be very challenging for the instructor, since the lab is outside, to go from one group then go to the other group. So at times it's time consuming. Sometimes students take action on their own, and then they lead with they end up with the wrong result. So immersive technologies, they can give us some solutions basically on that. So the instruction can be self-paced, either in virtual reality, augmented reality, or 360 videos. Because we're using augmented reality and 360 videos in the real location, representing the real site, the students, can see where things are supposed to be in space, so they can be better prepared. If they're working in virtual reality, they can complete the entire lab on their own, so we can create many environments. And for the question, challenge, students have access to the 360 videos through Kaltura during the lab, and also they can see everything from augmented reality using a tablet. So that can help them answer questions. Switching gears, we're going to talk a little bit about the environment, because it was like a big part of our project. In order to create a realistic environment of our campus, we used point cloud technologies. So images taken from drones and laser scanning. So the bottom left is a laser scanning point cloud. From these point clouds, we were able to get the terrain very accurately, and also get the geometric location of buildings. Next. And then with close-up photography, we were able to get these textures. For example, that's a brick wall, so that we can make it realistic. So the students, they will see whatever they see outside, they will also see it in the virtual environment. And that's an example of how we applied that texture to that part of the of that wall that we have in one of the buildings. And that's another view of, on the left side, you see the actual image from a drone, and on the right, you see the virtual environment. Now, that's also one of our, I guess, earlier versions. So we keep doing improvements as we go on to make it look more realistic. And these are examples of some of the textures that we have created. So we took close-up photography of the grass fields, and we created grass textures, of the curbs, and we created curbs, the lights outside of the tech center, we created stop signs. So we added all these, details to make the environment more rich.
Yeah, I just want to add that we didn't always have all these details. And we were finding that it broke the immersion. When you went into this kind of sterile environment, if it was lacking things like the lights and the stop signs, which really aren't necessary for the lab, it felt like a very alien experience for the students. So then we went back in and started adding some more of these details. Ideally, if we were meeting in person, we would switch to a demo, and I would show you how this would work by wearing a headset and some hand stuff. But given this technology, we're going to have to use some photos and some videos to kind of show you how this really works out. In the leveling lab, there are two instruments we rely on. The first instrument is the rod. I've been calling it a stick the whole time. It's essentially a big measuring tape. And if you look in the top right photo, it's the one that's kind of in the background. There's also a telescope, which I'm going to show you next, which is called the level. There are some procedures we had to do and some challenges we needed to overcome with virtual reality. We needed to be able to pick up the objects, and that turned out to be pretty simple given the current technology. But then we needed to be able to modify the position very accurately, nudge it left, nudge it right. And it just turned out that even with some very expensive hardware, we could not track the location of the hands like we'd want to. So we had to come up with a workaround, one that didn't interfere with the learning objectives for the lab. So in our case, what we did was we created an iPad interface. So as the person is interacting in the lab, they can bring up a tablet in their left hand. And that tablet has granular control that allows the user to get the fine, detailed, precise movements that just aren't possible by reaching out and touching these things. Another problem we ran into was that the avatars don't have feet, and pacing off distances is something that's important in this lab. So we came up with a unique solution of creating a virtual pedometer on the iPad. So while the students can't actually see their feet in the lab, they could monitor how many steps they took, and that's good enough to be able to do the calculations. A few other things we had to overcome: bubble levels. The physics is very easy in the real world, not so much in the virtual world. And being able to drop things like monuments all required different types of interactions, and it turned out to be a little bit more complicated than we originally thought. The other device, the other instrument that students interact with is called the level. For the longest time, I called it the telescope thing on the tripod. And it essentially is a telescope. Students can look through it and take a measurement from the rod. But just like the rod, you can't get precise control by reaching out and moving it. So we use the same interface on the virtual iPad that allows you to do precise control. You could adjust each leg independently. You could adjust the focus. You can even adjust the screws on the base of the level. If you look in the bottom left corner, it's a little hard to see, but there's actually 3 black screws. Using the pointer and the iPad, you can select any screw and raise and lower them to level the device. The other problem we ran into was it is difficult to bend over and look through the telescope. It's like eye fatigue. It's not the most comfortable thing to do. So we took the view from the telescope and we duplicated it onto the iPad. So if you go to the bottom, one from the left is a picture of the student adjusting the rotation, and they get a picture, which is the same picture you would see if you bent over and looked through it. So we had to find analogs for a lot of the learning objectives, but we were able to find a solution for every single one of the problems so far. Next, the students had to be able to take a measurement. And we didn't want them to have to take off the headset, put down the hands, and take a real world measurement. Because once they're immersed in this environment, we wanted to hold on to that immersion. So what we did in this case was we made a virtual field book. On that same iPad, students can bring up rows and columns, and it works just like Excel. They can click on any cell. They can then write in some of their information. The iPad is exported to a PDF. So when the students are done with the lab, they can click a button and they get a printout of all their measurements. Now, we also have some reports for the instructors. The second picture, the lower one on this slide, It's an example of the report that gets generated for the instructor. Every time a student puts data in the field book, a few things happen. We capture the real exact location of the rod and the tripod. We do a distance measurement between them so we know exactly how far apart they are. We record what the student was writing down and highlight it in yellow so we know what the student observed. We take a screenshot of that telescope so we know exactly what the value is. And what this will do, and we can't do this in the real world, is it lets an instructor figure out exactly when the student made the error. So we can see the observation the student made, we can see what the value really should be, and we can see what they wrote down, and it's made it pretty easy to figure out where the errors have been occurring. Now, before I go to the next slide, I just want to preference this by saying, we have a video of this happening, so I'm going to show you, or we're going to show you the video playing. Keep in mind a few things. The quality is going to be downgraded over Zoom, so it'll probably be a little jittery right now, but it's very smooth in the real world. Also, the video is kind of clipped. So when you're wearing the headset, you do get a true 180 degree or close to 180 degree vision, but we're going to see a little bit more narrow view, and that's just a recording issue. So let me move over to that, and Bolkas can kind of narrate what's going on here.
So basically, we have that leveling rod, measuring rod, and we pick it up, we put it on the monument. So it needs to be on the monument, and we have to level it. And that's where, as Jeff mentioned, we're using those buttons to level them more accurately. And then once we are done, we also have to change the orientation so that the person at the instrument can be able to see the measuring side, the graduated side of the rod. Then we go to the instrument, we pick it up, we put it in, let's say, in one location that we wanted to, usually we put it in the midpoint between two monuments or 2 points that we want to estimate the height difference. The whole procedure is that we are trying to find height differences between 2 points. And by taking this measurement of this graduated rod, we can find the height difference. So first, we level the differential level instrument by picking up or adjusting the tripod legs, and then we do more fine movements in the leveling screws. So that was what I was doing previously, and then rotate the instrument. We have a focus knob, right? So that based on the distance of how far is the object, we will have to use the focus knob. So after that, you will see me clicking on that. And then there is also an eyepiece that is making sure that the crosshair that you're looking is very clear. That is, based on the eyes of every person. And then after you take a measurement, we will record that measurement. So whatever height we see, and then we take the rod, we go to a second point. So I put like a position, like a mark. I dropped like a rail spike as a temporary point. So I'm going to move that over there, and we'll repeat the process. And for the sake of time, we will not play the entire video, but I think we have provided a link to that. So just to give you an example of how we have used those virtual reality labs in the actual, in the course. So that's an example of one of the labs that we did. Students, they know the elevation at benchmark 1 in the left side of the image. They have to find the elevation of benchmark 2 and benchmark 3 and go back to benchmark 1. So that's a simple task for them. We designed it so that doesn't take more than 20-30 minutes. So this case, they will not be more, symptoms from the student in terms of nausea and dizziness and fatigue from using virtual reality. Now we also did some, we added a few things like some challenges. So we added, we put monuments next to signs so that will block the line of view of the instrument. We also put some cars in front of those monuments so that students, they have to decide where they're gonna place, the leveling instrument, and also take into account the terrain factor. Usually all the labs take place, again, looking at the left image, on the right side of the big field area. So, so we kind of tweaked it and we did some of the labs basically on that left side where is the parking lot. Next. And we also did a lab in a city environment. Now the city environment was free, we didn't create it, but it didn't have cars, it doesn't have people. That's one of the things that we want to add in the future so we can make it more realistic. But hopefully, that lab will turn out to be something where students will have that city, serving in the city environment, something that can be kind of, dangerous a little bit. There's a lot of liability and cost involved if we actually want to train students, serving in the city. So in terms of assessment, we had several questions that we asked to the students and to get feedback. We first implemented in a freshman class, so that's the first class students taking surveying, and there were 7 students who were participating in the virtual reality labs. The 3 main questions that we want to focus are if the virtual reality labs help students understand surveying methods and techniques, if they help them understand how to operate the surveying instruments, and if the virtual reality can help them prepare for the real labs. Most of the scores are about 3.8 to 4.2, 4.3. And one of the reasons for the lower scores is that virtual reality, it comes with symptoms of nausea and dizziness, right? So it can be, it's great, you're excited that you will use it, but as you use it and you have these symptoms, it takes all the fun out of it. From those students, there were 3 that had 3 students had more severe symptoms. I could see a student that he was sweating a lot while he was doing the lab. And so students, sometimes they had to take some breaks and say, well, I have to, take a break. One decided to stop completely. He's like, I cannot do that anymore. And another student, for example, decided to complete one of the labs at a later point. But that's one of the limitations, I guess, of virtual reality that, kind of take the fun out of, the whole experience. Now, switching gears to the immersive videos, we basically had a 360 camera, and we captured 180-degree videos from both sides, from both fronts. We stitched those together, and so that gave us that 360 picture. Next.
And actually, I have copies of these
yeah,
360 videos, and they're in your chat. Again, they're best experienced on a device where you can look around or wearing some sort of visor, but they do give you that spatial feeling. You are able to look around while these videos are playing. Information is added. Well, because I know you can say a little bit more about what's going on here.
So you can see here that it gives in that particular case that spatial awareness, so they see where we are and where we're gonna go, so they can follow the same steps at the lab out when they're doing outside. We add text. We have added videos as well. So if you go to the next picture, the next slide, you will see that on the left, we have image that identifies key elements from the instruments. And on the right, we have embedded videos that they show, what I'm actually clicking on the software of the instrument, so that students can go back. If they're in the field, they can view these from Kaltura, and they can see what they actually have to click. So we use the 360 videos to prepare them, but they also were available in Kaltura. Click next.
And our latest endeavor is augmented reality. And frankly, we're just starting this. I'll let Dimitrios tell you a little bit about what we're doing with it.
Well, actually, I think there was a slide with
there is. I cut it to try to save a little bit of time.
Okay.
I can go back to that though.
Okay, so I just wanted to show you that there were the same questions, and we had, we tested the 360 videos in 5 labs. You will see that the scores are higher, 4.7, 4.6. That's because, it's easier for the students. They don't have so many symptoms. So it's easier for the students to experience, immersive videos than it is virtual reality. And yeah, going to the next slide, Jeff. So our newest endeavor is augmented reality. So we use, GPS coordinates to make sure that everything that we create will be on the same place. students, as the same way as I'm showing in the pictures, students will hold the tablet and they will start seeing things, in the real environment. So in the left side, you see someone, holding a rod. On the right side, you see someone with the instrument, and we can guide them through with instructions like going to the next scene and so on, or what are the steps that they have to follow.
So just to wrap up, I know there's a couple of questions here. Every time we're talking about an iPad, I should be saying tablet. It's not like it's branded Apple. I just have a habit of saying iPad. But the iPad is completely virtual. There's no need for a physical tablet of any sort. There's also a questions about after virtual lab, can students use the real equipment? And we're not trying to replace, traditional outside labs. We're trying to augment them. We have a very small sample from the study we did so far. And we're hoping, depending on the COVID situation, to expand that to a second point this fall at West Point to be able to better answer that question. But it appears through our little pilot that students who complete the labs do tend to understand the physical lab better. I can let Bolkas expand on that.
Yeah, so what we're seeing in terms of general conclusions is that the 360 videos really help students understand what they have to do in the actual field, so they were better prepared. But the virtual reality also, despite the main symptoms, it kind of was still able to give the students some extra skills, I would say, that they couldn't enhance some of the things that we're doing in the actual labs. And in the future, we are, in terms of what we're doing in the future, we keep developing more videos. We will apply or test augmented reality this fall. So that was a new thing. And we want to see how all these interact as well with each other. And we want to add more environments, make it more rich, more options in terms of labs, and also move to other courses in the program so that we can enhance the overall experience.
I think we're just about out of time.
Go ahead and finish your thought there, Jeff.
Great. I wasn't sure. I was keeping track of multiple things. There was a question about reducing nausea with a virtual nose. And I have seen some stuff like that. We just haven't had a chance to really try those things out yet. We have virtual avatars, and we're currently working on multiplayer where you can see multiple people and you can work collaboratively in this environment. But we're just starting to work on things like that.
Thank you. Thank you both so much for sharing your innovative solutions using immersive technology to address the challenges in your courses. This was really informative and very helpful. While we give our presenters a minute to transition to our next slide, one of our presenters who is presenting next week, Eric Ford, has asked us to share a pre-session survey with the audience so he can get some information from the audience and kind of tailor his presentation to that. His presentation is titled Integrating Jupyter Notebooks, Version Control in GitHub Classroom. So Tim's going to post that link in chat. And if you have a second, please take a minute to take that survey so we can get some information to Eric. While we're giving Carol a chance to set up, we have a quick Penn State trivia poll. So I'm going to launch that. Our first question is the Learning Design Summer Camp, LDSC, that's being offered in July this year is in its which year? 5th, 10th, 15th, or 25th? So for those of you who are active in the learning design community, that's offered annually. So which year is it in? And then number 2, a team of researchers from Penn State, University of Minnesota, and 2 Japanese universities announced that a handheld device may kill coronavirus using what? So I'll give you a few more seconds, and then I'm going to end the poll and share the results. And Jeff and Dimitrios, if you have time, there are, I think, a few more questions popping up in the Q&A. If you could answer those by typing your answers, that would be great. Okay, so the LDSC is